Just what? Okay.
There it is. Okay, this is our group 9 work problem. I don't know, I always have a hard time saying that.
No, you're good.
Okay, so for question number 1, it's asking us to draw the diagram for DNA replication, pretty much. And it is asking us to include the, let me pull it up. Elijah, no. Okay, the ORIC, DNA primase, DNA helicase, RNA primers for leading and lagging strands, 2 leading strands, DNA poly 1, DNA poly 3, alpha subunit, and the Okazaki fragments. And then here we just show, can you see that? Okay, so here we have on the 3' end, on the left side we have the helicase. Then you have the DNA primase on the bottom next to it. Then you have a DNA polymerase 1. Following that, this the lagging strand is on the 3' to 5' strand. The Okazaki fragments go in between them. And then here at this point is the ORIC. The leading strand is from 3' to 5', but on the top. And then you have DNA polymerase 3. And then the RNA primers. And here you go, you can look at that. Sorry, my baby's moving my laptop. Okay, and for number 2, it is, she's asking, it's filling the blank. And for A, we got DNA polymerase alpha is the protein complex that synthesizes primers in eukaryotes. DNA A is the protein that promotes the separation. Sorry. Okay. Is the protein that promotes the separation of the AT-rich sequences. I'm so sorry.
You're good.
Within just let me pull this up. Within the ORIC. For C is the epsilon is the subunit of DNA polymerase 3 that contains proofreading activity. For D is DNA polymerase epsilon is the protein synthesis, the leading strand in eukaryotes. For E, TUS is the protein that displaces DNA polymerase 3 from the chromosome to terminate replication. For F is DNA polymerase 1 is the protein that has the 5'3" polymerase and 5'3" exonuclease activity. For G, DNA gyrase is the protein that introduces negative supercoils into the DNA ahead of the replication fork. For H is the ORC, and this protein introduces negative supercoils into the DNA ahead of the replication. Did I say that? Nope. Sorry. ORC is for H, which is the protein that binds directly to the ARS elements. For I is the ISSVP, and that's the protein that prevents DNA strands from annealing during replication. And then J is the DNA ligase, and that's the enzyme that seals the Okazaki fragments into a continuous strand of DNA. And then all those answers can be found in the reading. For question 3, is asking us the enzymes involved in DNA replication. And then for part A, it says list 5 enzymes prokaryotic or eukaryotic that consume ATP during DNA replication. And then for that, we got DNA helicase, DNA gyrase, DNA primase, DNA ligase, and the MCM helicase. For B, list 5 enzymes that consume DATP during DNA replication. And we got DNA polymerase 3, epsilon 3, alpha 3, delta 3, DNA polymerase 1. For C, list 5 enzymes that have 3 to 5 exonuclease activity. And we got DNA polymerase 1, DNA poly 2, epsilon, alpha, delta, and DNA poly 3. For D, indicate one enzyme involved in replication. Okay, I lost the answer, but the question, but it's DNA prime. And then for E, we got telomerase. I'm so sorry about that.
No, you're totally fine. And just for the DNA primase, I don't know if that's going to make a difference or not, but prime sounds good too. Okay, so for question 4, here I'm going to try and hold this and read this. Always pretty awkward here. Okay, so they say that you are trying to synthesize DNA in the lab. They give you a single strand, and that's the template for the reaction. And they say that it is mixed with DNA poly 3 and this primer, and they give you the sequence. And so there's a buffer containing manganese, which is the cofactor for the polymerase activity. So then it goes on to say that you perform 4 DNA synthesis reactions to determine the sequence of the DNA synthesized if you use the molecules described in part A through D in your experiment. Assume that if the DNA polymerase cannot incorporate a nucleotide into the nucleic acid strand, then it will terminate, and so you don't need to write the whole thing. So I first have the strand that they gave us, and then I did the complementary strand, and then I highlighted what the primer would be. So in part A, they are all good nucleosides, so I just wrote the rest of the sequence that wasn't the primer. Then in part D, in part B, they changed the second nucleoside, which is DCMP, and so because of that, the strand will only have an A. And then in part C, they change the DTTP to UTP, and so you're only going to have AC for your strand. And then part D, they go from a deoxyguanine triphosphate to just a guanine triphosphate, and so you only are going to have 3 letters, which is the first 3, A, C, T, and that's part 4. And then for 5, they give you a list of proteins involved in DNA replication, and they want to know, like, which one is going to be found in there. So the first one is what proteins are found in prokaryotes, which would be, we got DNA gyrase, TUF, DNA poly 3 alpha, DNA poly 1, DNA primase, and DNA A. For B, they wanted to know what is found in the MUS musculus, I think that's how you say it, and the MCM helicase, DNA poly epsilon, CDC6, DNA primase, PCNA, DNA poly alpha, and the telomerase. Then in C, they wanted to know which is involved in chromosome compaction, which would be DNA gyrase. In part D, they wanted to know what's involved in the initiation stage of DNA replication, and that's DNA A and CDC6. And then in part E, they want to know what's involved in termination, and that would be the TUS and the MCM helicase. And that's what we got.